Hello, everybody, and welcome to the Splunk session on code to cloud visibility and observability. Thanks for joining us today. I know that there are a ton of sessions and content you get to enjoy, so I appreciate you taking the time to come and join us. My name is Chris Riley. I am a DevOps advocate here at Splunk. What does that mean? I'm basically a bad coder turned advocate. So while I didn't make it my career as a software developer, I really enjoy talking about modern development practices. I'm joined with one of our actual DevOps engineers. His name is Eddie, and he's going to join me today in giving a demo around how Splunk and both our technology and us implement DevOps and visibility. So our agenda, I want to talk to you today about what's happening in modern delivery chains and why we need to rethink how we treat the SDLC. I want to give you a pitch for this idea of code to cloud visibility and why that should be the goal of any DevOps team. I want to talk to you both about how pipeline analytics and observability fit into that. And then finally, talk about what you do with the data, because we've all seen the DevOps infinity loop. How do you complete that loop? A lot of organizations are not. So first, we all have to buy into one simple premise, or it seems simple. Applications are changing. I think we already understand that intuitively, and it seems obvious. But one thing that is interesting about this is that we have a tendency to want to believe that they change and that's it. Like some point you hit an end game and that's it. But the reality is the way we build, the way applications work, they are always changing. It's not just a one-time cycle and you're done. We have to embrace this idea that change is going to happen forever. Because after all, if it doesn't, then we get into the situation where we're simply dealing with waterfall. And we don't want DevOps to become waterfall. That's not the premise of modern software delivery. So what used to be a scenario where we would have a server and we would give the server a name from the Billy Bob server, and we deployed code to this static infrastructure has changed. In that model, the monolithic model, which I'm sure you've heard of, we were deploying monthly, in a good scenario, monthly. And our application architectures and the infrastructure were not related to each other because we didn't really have a need. The Billy Bob server is where we deployed our code. Every other week, the Billy Bob server would get a disk full error. We address it, we turn it off and on, and then that's it. In that scenario, we could start with logs. We didn't really have to think too much about our monitoring practices because we knew exactly where the problem is. Well, that scenario no longer exists. Now we're deploying applications frequently. We are using AWS. We can spin up infrastructure rapidly. We can tear it down rapidly. We can deploy applications faster than we ever thought before. Maybe we're using serverless, which these serverless functions spin up in seconds and die within milliseconds after they're being used. So things are different. We also have microservices. Each microservice has its own stack. They're all distributed. The relationship between the services, both ingoing and outgoing, are complicated. Even if you have 10 services, it's complicated, much less a typical environment which has 50 to hundreds to thousands of these services. Transaction volumes are increasing. So all of this complexity, including the demands from our user, are making it more and more difficult to keep on top of our infrastructure and manage our applications in production. And it's impossible for support people to operations folks to keep on top of the change and know exactly where problems lie. So as applications change, the management plane also has to change. A lot of times when we talk about DevOps, we like to refer to velocity and how to ship code fast. But that velocity is not sustainable long term without making your management plane keep parity with it. And it not only impacts the application, it impacts the security of the application. Automation is not an option. Automation is necessary. You have to automate. You have to automate as much as you can. Previously, you would have a NOC that was supporting your application in production. Now everybody's on call, or anybody can be on call. And a lot of times developers are on call for the applications that they build. Not only are we running into this problem with the infrastructure side of it in the architectures, we have visibility silos. So developers might have clear visibility into their portion of the delivery chain. Security professionals and IT professionals, their visibility starts only after prod. And so they don't really know anything that's happening in the delivery chain up until that point. Maybe DevOps engineers have a certain slice of visibility for the automation that they've built. The problem with these visibility silos is that nobody's speaking the same language. So the amount of time it takes to centralize and get everybody on the same page when there is an incident is tremendous. It's a huge waste of time. Not only that, is there's no feedback loop. There's no learning from what happens into production back into your planning and your ticketing and your product activities. So what does this all come down to? Well, hopefully you're on the same page with me that applications are changing. They're always changing. And your SDLC, you have to create visibility across it. The only way to create visibility is data. Telemetry that comes from your tools, telemetry that comes from your application, telemetry in production. And leverage that to understand what's going on throughout the entire development lifecycle to prod and all the way into the area of security in managing your application in production. So how do you do that? Well, that data can't just be there. It can't be nascent data. It has to translate into value. And we like to talk about this idea of code to cloud visibility, where your delivery chain, which is essentially a product that you're building for your customers, and the operation side of it is also a product for your developers and your customers, has to have both depth and breadth. So the monitoring side of it, observability, your SIM, the security is depth. Breadth is what we call pipeline analytics that butters across the entire delivery chain. So I'm going to explain to you what those two key components are. Pipeline analytics is how you monitor, secure, and measure your application of applications. If your delivery chain goes down, you can't ship code. Simple as that. The reason we do pipeline analytics is to create that visibility and give IT professionals and security professionals a chance to know what happened during application development to make sure that it's secure and find out what developers are doing to build better, more secure applications. We also use it as a way to create measures of success. How do you know that your velocity is working out if you can't measure the success of that application velocity? We want to align the SDLC with business value, called value stream. We need to make sure that we're meeting our SLOs, our internal objectives. And again, create continuity, a single language across teams so that security people, when an incident happens and there's a vulnerability that is related to the application, security professionals can speak the same language as the developers and collaborate together to resolve that incident faster. What is pipeline analytics? It's monitoring of your SDLC. We're used to monitoring applications, so that's pretty straightforward. For the purpose of, again, metrics and also security and compliance. Because if people get access to your delivery chain, that's not good either, just like getting access to data in production. The way you do it is pretty straightforward. You collect metrics and logs from the tools in your delivery chain, and you visualize that data, and then you correlate it. The common tools we see here break down into 5 categories: DevSecOps, CI/CD, testing, orchestration, and incident response. And on the measuring success side, you're looking at things like MTTR, cost of downtime, number of outstanding incidents, cost to number of hours spent, time spent resolving incidents, which is unplanned work. You're also going to be looking at things like, how do we make sure bad actors are not accessing our delivery chain or tools inside of the delivery chain? There's things called the DORA metrics and flow metrics that are published places for organizations to start here. So now that we have the breadth with pipeline analytics, let's talk about observability. Why observability? Is it another term for monitoring? Yeah, it sort of is. But as everything that I just said, things are changing. We need a new way to describe those. So that's why we use the term observability. And application velocity, increased complexity, needs a new approach. So to look at observability, we're going to be looking at applications that are distributed beyond the human ability just to navigate these applications. We're going to look at observability when incidents are not something that we can just go spend time hunting down because we don't know what service is the cause of an incident. We need the platform to tell us where the issue actually lies. We're going to look at it as a tool to get more context to security professionals and operations professionals to support mean time to recovery. And as application stacks become more varied, because that context is also important if I am supporting an application that I didn't necessarily build and know much about. Observability is not a tool. Observability is really the data, and the practice of observability is building lenses on top of that. So it's a strategy first and a tool second. And really what we're trying to do is take that amazing strategy of site reliability engineering and bringing it in to practice for the entire development organization. How do we do observability? Well, we need to think about monitoring differently. We need to think of monitoring as a push activity, not a pull activity. So the technology needs to tell me what's going on versus me going and hunting for it. There is one key component to observability, which is the need to gather traces and spans. It's a new type of data set that follows the user's transaction once it enters the system and it leaves the system. And we need to focus on the customer, because back in the day of monolithic applications, we were basically looking at the server as the customer. Now our end users are too demanding, and we need to look at things like latency as a new form of downtime. Because if I click a button on an application, it's not responsive, it might as well be down from my perspective. Another part of the observability practice is really solid incident response. Because once the observability tool gives us the alert, we need to be able to take that data and act on it. And the only way to act on it is to mobilize the right people at the right place at the right time. And that is incident response. A lot happens in incident response. You need to be able to get to engineers in the appropriate way. If they're sleeping, it needs to be a phone call maybe, not a text message or an email. Now, incident response is tied to observability and in the way that it gets the context from an alert and gets it out to the on-call engineers as quickly as possible. Sometimes confused with incident management, which is where you track and store incidents over a period of time. That's your system of record. One way to think about it is observability is the alert, like the engine light on your car, all of the diagnostic data from your car, Incident response is the roadside assistance that gets there as quickly as possible to try to help you triage the problem. And incident management is kind of like your Carfax or your system of record for that. So I've been talking a lot about what all of this is, and now I'd like to take an opportunity to show you a demo. So I'm going to show you a demo of our observability suite, which is incident response and observability with traces and spans. And Eddie is going to take that one step further to show you a demo of how we do pipeline analytics. All right, let's take a look at how a workflow for a microservices-based application in a cloud-native environment come together with the Splunk Observability Suite. Now, the first place you're going to start, of course, is an alert. The Splunk On-Call platform is designed to get you to the right place at the right time and with the right data. We're looking now at a series of alerts from Splunk APM, but I probably got the actual alert on my phone. Splunk On-Call takes the details from observability to create an incident. It adds the ability to create rules, identify responders based on incident history, and see similar incidents, giving those on call a better solution for MTTA and MTTR. Now I can open an alert and see all the details like environment, host, and threshold being hit. In the annotations tab, I can actually see a screenshot from APM, as well as other details like runbooks and articles related to alerts of this type. Now we click into APM. I can see I have an increase in error rate somewhere. I can look at it from a troubleshooting basis here, but let's look at it more from a broader APM side, because for now, we suspect the issue is somewhere within the application, but do not know exactly the service that is causing it. So this is a service map for application and the relationship between applications. It gives me red metrics, rate, error, and duration, and often the starting point for any troubleshooting. The service map is powerful to determine how transactions flow through the system to better identify exactly where an alert is originating. All of this is based on traces and spans data. Here we see the API, checkout, and payment service seem to be having the greatest number of errors, but so do authorization and LDP. The alert was originally fired by the gateway, which might seem to be the root cause, but in a microservices application, we don't really know. And this issue is likely caused somewhere downstream. If I click into the dashboard, we get even more detail on the red metrics at the application level. I can see details into endpoints. This is a really great regularly accessed dashboard for the entire team and might always be up and giving you the general status of things for regular ongoing monitoring, but might not be where you start troubleshooting. Here we need more than just application metrics. This view also gives me host metrics and Kubernetes pod metrics. So I have details about what is happening across both application and infrastructure boundaries. This is critical because application infrastructure boundaries are blurring and SREs need to know that because it's not separate like it used to be. Not just a slice of it. So now back to the service map. Let's get back into troubleshooting mode. Here I get additional information, and we suspect that this is where you're going to spend most of your time. So in the service map, I can see the extent of the issues and the relationship between all other services. The other thing we have to think about here, of course, is how an incident might cascade by looking at the dependencies. The size of the red dot shows the magnitude of the error. The yellow line is showing the path where the increase in errors and latency are flowing. Now it shows 223 milliseconds between API and checkout. Hovering over any service will give me the red metrics for that service or the relationship between them. And I can click into the API service to get more details. And I see that I have a 402 error happening somewhere in payments. And I can see infrastructure details such as pods and tags such as tenant. These details start to lead me to identify root cause for the lowest instrumented service. it looks like the flow of issues are leading from API to checkout and then to payment. So we have a good sense that payment is where the lowest level service, where the issue actually is. And we can see that even with a handful of services like this type of navigation can get hard, but a lot of applications have even more. So now we know that payment is a problem. We can slice and dice based on other data, namely tags. So now I can look at the tenants tag, which is how we are identifying the customer groups, so being impacted. So we see that our platinum and gold users are being impacted, but not silver. And I'm now wondering if this is a versions problem. So if I filtering by the versions tag, we see here that the versions are acting the same. So it does not seem to be a deployment version issue. So the next thing to think about is infrastructure. So let's look at the Kubernetes level and the infrastructure level. And finally, it looks like we're getting to the issue. A particular pod is causing a spike. So now let's look at what is happening in that pod by looking at the tag spotlight just for that pod. Tags are a very important tool in traces and spans to give you more context. And now I am looking at all the tags in one place and along with the metrics. And we can see here there's a spike in latency. If I click into the graph where the errors are, I can get the traces along with the tags. And finally, we're getting to the root of it all. I can see that we are getting a 402 error in the payment/execute endpoint. And can see all the details of where the transaction spent its time. What is important to know about this is that the platform keeps all of the trace data. This full fidelity is important to catch all possible outliers. If you don't have the data, then you can't expect to support it or troubleshoot it. All right, so now we know the cause, and we can go back to the service map and start to attack the issue. We now know that the problem for sure is in the payment service. So now it's time to start thinking about finding what in that service is causing the problem. So we're going to go in and investigate the Kubernetes node for the service because we know that this is where the actual issue lies. And when we do that, we now see the infrastructure metrics for the Kubernetes node. And I can quickly see that I have a memory issue. So now I will click on the container where that memory issue is. And we will start to get more details. And there seems to be a bad configuration that somehow made it to prod, where we have an unlimited memory value set. This is not unusual, but this type of operational drift impacts everybody. The solution would be to set a memory limit, but this is not the end of the story. Why is the memory being tapped out to begin with? Seems like an application memory leak in the application itself. So for that, we want to jump into the details at the log level. So from here, we can dump into Splunk interface, and now I can see the entire error, all of the details to share with the developers to resolve fully the issue on the application side as well. So the demo fun has just begun. I just did a demo that is showing you Splunk and the observability suite from incident response down to the observability traces and spans. Now Eddie, and again, that's the breadth or the depth, in the delivery chain. Now Eddie is going to show you the breadth by showing you how you can get telemetry data from your delivery chain and monitor and create visibility before that code even hits production.
Thanks, Chris. Hi, everyone. My name is Eddie Shafak, and I'm a DevOps engineer at Splunk, based out of San Francisco. So, as Chris mentioned, I wanted to talk to you guys a little bit about monitoring your critical services and monitoring your DevOps build pipeline. So, as we can see, we have our artifactory dashboard up here. And on the upper left-hand side, we can see the number of database connections as a total, but also the number of database connections coming from each node. And that's important to us because that identifies the service usage on the back end. On the upper right-hand side, we can see the artifactory API load, and this is front-end and back-end load. And we can see that it's categorized by Docker, NPM, PyPy, NuGet, and a couple of the built-in facilities like storage and search that Artifactory provides. Below that, we can see a timeline of the number of database connections over a 7-day period. This just gives us an indication of whether the database connections are at a healthy number. Below that, we can see the upload and download rate per repository. So we can start to gauge how much repositories are being used and how much bandwidth they're taking in terms of upload and download. The API metric I mentioned earlier, we can see non-API requests coming in from PyPy, Docker, and NPM. These are the highly utilized repositories that we use in Artifactory. And one of the things we found that when one request for PyPy in particular that comes in the front end, it translates to an average of about 14 requests on the back end. So if we move on to the next slide, we can see the Artifactory service load. And so this just gives us a general idea of how many requests are coming into Artifactory. So if there's a big spike, we can further investigate and drill down. We also divvy things up by HTTP status. So we can see the response time of Artifactory with every request by HTTP status. We can see the repositories themselves if we want to silo and check out just NPM or Docker. And then we can see the HTTP method that shows us, okay, if a request did get accepted, what method was used to initiate that request? If it was a delete or a get or a post or a put. If we move on to the next slide, this gives us an indication of how much is being uploaded to Artifactory. And as you can see, these peaks and troughs indicate kind of a healthy service in terms of usage. It gets used as expected during the week, and then over the weekend we have some usage, but it's not as stringent on the service as it is during the week. Below that, you can see the branches that are uploaded the most. So after we get artifacts and run it through our CI, we can see after those artifacts are posted which branches or which repositories that correspond to branches that they get posted to. I wanted to talk a little bit about the database and monitoring the database. We can see what the database itself is doing, and this helps us rule out kind of inefficiencies or efficiencies in the database in terms of whether what the load that's coming in is Artifactory behaving as expected when it's making requests to the Postgres database. And this is a little too much detail in my opinion, but this helps us rule out whether the database is functioning properly or not. I mentioned pipeline analytics. And so at Splunk, we have this process. When we merge code into develop, it needs to pass DOM. And what DOM is definition of merge. So when a developer thinks his code is ready and wants to merge it, he needs to run a suite of tests, front-end and back-end unit tests, regression tests, and build the product. And so what we did in this process is introduced an optimization. And that optimization was essentially a tool chain with the latest and greatest tools to build and test the product. So we introduced this tool chain, and we noticed that we saw the speed of the build drastically reduce. And we were able to measure that before and after. Obviously, this is the after period. The before build time was about 60 minutes, and the reduction ended up being around 30 minutes. So we can see up top that the average build time is about 30 minutes. Below that, we can see that the below that we can see that the stages in the build pipeline are measured out. And so we can measure the sync stage, the contrib stage, the build stage, the packaging stage, and the publishing stage. And so this gives us an overall build reduction or overall workflow reduction of about 30 minutes. So below that, we can see what percentage of builds that run through the CI run on this optimized build tool chain. And beside that, we can see the total number of builds. And beside that, we can see the actual measurement that we care about, which was the one that was greatly reduced, which is build time. And so we can measure and see who's using it, what users are using it right down below, and how many times it's being used during the week. And so this gives us a better idea or perspective about changes that we introduce to the build pipeline. So how can you guys start to implement or get some of this data into your Splunk instance? Well, if you use Artifactory like we do, you can go to Splunk Base and download the JFrog Platform Log Analytics app. And if you use Jenkins like we do, you can go to Splunk Base and download the Splunk app for Jenkins. Keep in mind, you'll need to download the Splunk plugin for Jenkins on the Jenkins website. And if you're using pipelines, you'll need to download the Splunk extension for Jenkins as well. So thank you for your time. I will kick it back to Chris. Thanks.
Great. Thanks, Eddie. Thanks for giving us that awesome demo. And I have to say, I'm partial to pipeline analytics. Yes, I'm like any developer who thinks those metrics and KPIs are really cool. But understanding the benefit of using pipeline analytics to create a unified language across your entire environment and also give your security professionals an opportunity to speak the same language with you is fantastic. So I just want to wrap it up. It's exciting to be able to join a peer in the DevOps field, talk about how this is being done, because Splunk is a partner in your DevOps and digital transformation journey. Just a reminder, it's always changing. This is never going to stop. And you have to think about supporting the velocity in your application by data. Data is the connective tissue across your SDLC, which is your application of applications. And once you accomplish this, you are creating true code to cloud visibility that's going to make sure that you and your entire development team can continue to advance your practices and the technology they use in the cloud and across your entire software delivery chain. Thank you so much for joining us today. Enjoy all the sessions, ton of content out there, and we really enjoyed having you and giving us a chance to talk about our technology and our vision around code to cloud visibility.